It says the price of a new motorcycle is $18,000 according to the summer group. The value of a motorcycle will be $7,200 in 6 years. Write a linear equation that gives the value of the motorcycle in terms of its age. Use the equation to find the value of the motorcycle in 4 years. So we got to figure out what we're dealing with here, and we got to figure out independent variable and dependent variable. Independent is going to be on the horizontal axis, X, and the dependent on the Y. So what are the things that we have in this problem? What are the two things that they're talking about?
Year cost.
Okay, the year, right, and the value, right? So the year, and value, or if you want to, cost. Which is the independent, which is going to be the X and which is going to be the Y? What drives the other one? Does the cost drive the year, or does the year drive the cost? Okay, so the year drives the cost, so the year is called the independent variable. This is called the independent variable. And we always graph the independent variable, what? Horizontally or vertically? Okay, so this is going to be X. So that means the value or cost is going to be dependent upon the year, right? So that's a dependent variable. And we will have that on the Y. So when we graph it, we're going to have cost, if you want, here, and we're going to have years. So in terms of ordered pairs, because we got to write an equation, and we either got to use one of two things. We got to use the equation y minus y1 equals m x minus x1, or we got to use the y equals mx plus b. So what are a couple of things in terms of years and costs that we have? It says the new motorcycle this year is $18,000. According to this group, the motorcycle is $7,200 in 6 years. And then it says write the equation that gives the value of the line. That's the first thing. That's what we're trying to do. So what are some year cost relationships that you can say that's here? $18,000 would be in what year? $7,200 in 6 years is where? It's all going to be XY ordered pairs, right? So the 6 years, we got a 6, right? what would be the y value on 6? 7,200? Right? Okay, we got $18,000, which is a y value, right? What year is that? If 6 years is years from now, now it would be what? In terms of a number? 0, wouldn't it? So we got 2 ordered pairs, right? So I could go right here and I could say this point was represented by 0 years and what? 18,000. And then out here, whatever 6 years is, right? 6 years. 6 years would be the ordered pair what? So it'd be someplace up here. It wouldn't be quite halfway up. 9,000 would be halfway. 7,200 would be someplace here, right? And if we joined those 2 points, it'd look like that, right? So now, which one of these 2 equations do we use? This one we need a what? A point and a slope. And this we need a slope and a y-intercept. The second one is easier if you have a y-intercept, right? Both of them are going to require slope. Do we have a y-intercept? What is your y-intercept? Y-intercept is defined to be x is zero. Who said it? X is 0. So do we have an ordered pair in which x is 0? And that one is 0 what? So this is 0b, isn't it? Is that right? Can we use our second equation? Because we have the b. Now all we have to do to use the second equation is we got to get the m. Right? So in this second equation, we got 18,000 up here. The x is just a variable. Y is there. We've got to calculate what that b is, what that m is, excuse me. What's our equation for m? M is equal to what? Go ahead and say it out loud.
y1 minus y2 over x1 minus x2.
Okay, and you can say it the other way around. Y2 minus y1, over x2 minus x1. But either way is right, isn't it? So what do you want to do? What are you going to put in there? Does it make any difference which one we call x1, y1, and which one we call x2, y2? Does it make a difference? We can use either one as x2, y2, and either one for x1, y1. Doesn't make any difference. But we have to be consistent, right? If we use y2 from one ordered pair in the numerator, we've got to use x2 from that same ordered pair in the denominator, right? That's the only thing that makes any difference. So which y do you want to put in the numerator first? 18 or 7,200? Okay, 18,000 minus, that means we have to put the other y, and what is that one? 7,200. Now, what do we have to put for x2? What do we have to put first in the denominator? 0. Because it's the one related to the 18, right? And then we go minus, what's the x related to 72? 6. Now, could I have written this as 7,200 minus 18 over 6 minus 0? Would not make any difference, right? Still going to get the same number. It's just the minus sign is going to be in the denominator here and in the numerator here. So if we reduce this down, the numerator, if we use this particular one right here, the numerator is going to be what? What's it going to be when you take 18 minus 72? 10,800. And the denominator is minus 6. So that's going to be okay, negative 1,800. Can you tell me what negative 1,800 is telling you? What?
That's your answer.
That's the slope, right? So we would put a minus 1,800. Now, 1,800 is telling you what? For every year, the value of the motorcycle declines by $1,800. Is that right? That's what that's telling you. So this is the equation then of the line. What would I do to find the value of the motorcycle after 4 years? I'm going to use that equation, and what would I put where? In the back. Okay, that's right. I would take my equation and for x, I would put 4, right? So this, when I figure it out, is going to be y equals 4 times 18 is 72, is that right? Plus 18,000. So after 4 years, it's worth what? What'd you say? $10,800, right? So we've gotten the 2 things that they asked us for, right? The value of the motorcycle after 4 years and the equation. Could we find out what the value of the motorcycle was for any year? Yeah. Except would the value of the motorcycle ever go below 0? No. It'd be junk, right? So you'd either write it or else you'd sell it to a scrap company. It would have some value at the end. So this technically isn't a straight line throughout. Technically what a depreciation looks like is it comes down and then it flattens out. And then actually what happens if it's a 57 Chevy? It goes back up, right? Or any used car, old, and depending upon what kind of condition it is in, it can go pretty high. But in the first part of its life, it'll go down. When you drive it off the showroom floor, is it the same value as when it? No. You get a big depreciation drop. 78 says a jogger running 9 miles per hour burns 14 calories per minute. Write a linear equation for the number of calories burnt by the jogger in terms of the number of minutes run. Use your equation to find the number of calories one has burned after 32 minutes. Is this a similar problem to the last one? Yeah. So what do you think the independent variable is, x, and what's the dependent y? Does the number of minutes you run depend on the calories you burnt, or do the calories you burnt depend upon the minutes you run? The number of calories you burnt depends upon the minutes you run, right? So which one drives which? Okay, the minutes you run is going to drive calories burnt. So this is going to be minutes run, and this is going to be calories burnt. That being said, it says 9 miles per hour burns approximately, if you run 9 miles per hour, burns approximately 14 calories per minute. Now, if vertical is calories burnt, and minutes run is horizontal, the slope is going to be what? What will be the units for slope? Rise is going to be in terms of what? Calories burnt, and run is going to be in terms of minutes. Is there something in that problem that tells you calories burnt per minute? Which one is it? 14, right? So what would you say that 14 calories per minute would represent? I mean, we have a line that's basically, what would be the, how many calories have you burnt at 0 time? Okay, so at 0 time you burnt 0 calories, right? That's a point on your line. And then as you run minutes, what would the shape of that line look like? Would that line go this way? Would that line go this way? Would that line go that way? It's going to go up, right? The more minutes you run, you're going to increase the number of calories. So it's this kind of a shape. And for every minute, you're going to burn what? 14 calories. So what is 14 calories per minute? Slope, isn't it? rise over run, right? Now, which equation do you think you can use? The first one requires a what? A point and a slope. The second requires a slope and a y-intercept. Which one's easier to work with? The y-intercept. Do we have a y-intercept? What is the y-intercept? The y-intercept is when x is 0. In this case, when x is 0, y is 0, right? So if we can use this second equation, and for b we can put 0, correct? So y equals something x, and we said the m was what? 14. So does this equation look like y equals 14x? So how would you answer the second part of that question? Okay, put 32 in for x. What'd you say? So it'd be calories, wouldn't it? It'd be 448 calories are burnt after 32 minutes. So if you went to McDonald's and had a Big Mac meal, would you, after 32 minutes of running, have burnt off the calories? No. You would not have burnt off the calories. So then you would be what? You would be gaining weight. That's pretty sad, isn't it? Because I like to eat, and I don't like to run. How many like to eat, don't like to run? We're in trouble in this world, aren't we? Okay. So 80. Explain the point-slope formula cannot be used to find the equation of a line that is parallel to the y-axis. Okay, so a line parallel to the y-axis. Which line is parallel to the y-axis? Okay. So which line is parallel to the y-axis, Julian? You.
Was that, what was the question?
Can anybody tell her what the question was?
Which line was parallel to the y-axis?
Yeah.
Or did we get green?
Okay. You would know if you were paying attention right off the bat.
Maybe.
Okay. So the green is parallel. So the question is, explain why a point-slope formula cannot be used to find the equation of a line parallel to the y-axis. So point-slope is y minus y1 equals m x minus x1, right? So why can you not use that for a line parallel to the y-axis? What is the slope of a line parallel to the y-axis? Do you know? Right? Okay, the slope of a line parallel to the y-axis is undefined. So does that tell you why you cannot use the
What does that stand for?
what? Undefined slope? That black line is parallel to what? The x-axis. So this one, the slope is undefined. What's the slope of this line? That's right. Okay, 82 says for an equation of the form y equals mx plus b, how does the graph of this equation change if the value of b changes and the value of m remains constant? So if I take this line right here, its y-intercept, the b would be the y-intercept, wouldn't it? Its y-intercept is here, correct? Now if I draw another line parallel to it, are those slopes the same? But what has happened to the y-intercept? So is that describing what is going on? For an equation of the form y equals mx plus b, how does the graph of the equation change if the value b changes and the value of m remains constant? So the graph is what? A whole set of parallel lines, right? Okay. What we'll look at is section 4.6. Now, if we answer 1 and 2, it's going to help us do this set of problems. It says, number 1 says, explain how to determine whether the graphs of two lines are parallel. Okay. Did everyone hear what he said? Can you say it a little louder?
Same slope.
So those would be parallel lines, right? And the equation of slope-intercept form is y equals mx plus b. Now the slope of this line is m2, for example, and the slope of this line is m1. Now, for them not to be the same line, what has got to be true about this point B2 and that point B1? Parallel lines are lines lines where M1 equals M2, slopes are the same, and what? What about the y-intercepts? Can they be the same? Because if they're the same, what are they? Same line. So B1 is not equal to B2. Different y-intercepts, same slope. Parallel line. Number 2 says explain how to determine whether graph of two lines are perpendicular. So I'll just give you an example. If I have a slope of a line where it's 3/4, and if that line goes through this point right here, how would I find a representation of that line? Up 3 to the right 4, or right 4, up 3, right? So I'd go out here, 1, 2, 3, 4, and then 1, 2, 3. And I'd say that line looks like something like that, right? Now, if I have a line that is perpendicular to that, I'm on 4-6. Number 4. No, I'm doing number 2. This is what the slope is, minus 4/3. Notice that would say what? I'm right 3, 1, 2, 3, and down 1, 2, 3, 4. Down in there. Now, that would be what that might. Are they perpendicular? They're perpendicular. How are M1 and M2 related? M2 is what? Opposite or reciprocal? I've changed the 4 and the 3, right? Numerator and denominator. That's reciprocating, isn't it? And what have I also done to M1? Put a minus sign in front of it. 1 over M1. That's, if they're perpendicular, they're going to be negative reciprocals, the slopes. So if they're parallel, they are what? Kind of slopes are what? Okay, slopes are the same, right? If they're perpendicular, they're negative reciprocals. Now notice that if I multiply this by M1 on both sides, then an alternate form of this equation is M1 times M2 equals what? Negative 1. Their products are equal to a minus 1. The easiest thing to remember is that parallel lines have equal slope, different y-intercepts. Perpendicular lines, the slopes are negative inverses of each other. So number 4. It says the slope of the line is 3/2. So a line has a slope of 3/2. It says, what is the slope of a line parallel to the line? M2 is what? 3/2, right? Equal slopes. Parallel lines, equal slopes. 6 says the slope of a line is minus 4/5. What is the slope of a line perpendicular? Okay, you change the sign from minus to plus, and you invert the fraction, right? Line force. Perpendicular lines. Okay, 8. Is the line y equal 1/2 perpendicular to the line y equal minus 4? Well, if M1 equals 1/2 and perpendicular line M2 would have to equal what? Negative 2/1. So is all right. I'm just, I don't know what I'm talking about. This is not even, don't even make any sense. Y equals 1/2. What kind of a line is that? It's a horizontal line, right? 1/2. This is 1/2. It's a line that comes through here like this. Correct? Okay, y equals a minus 4. What kind of a line is that? It's horizontal, it goes through there, right? So, does line y equal 1/2 perpendicular to the line y equal minus 4? No. What are they? Parallel. So 10, it says if your line x equals 4 and x equal minus 4, are they parallel? Okay, so if x equals plus 4, there's plus 4 out here, how would you draw the line through it? Vertical line. So this would be represented by a vertical line. And x equal minus 4, yeah, minus 4, and the line represented there would be, and the question is the line x equal 4 parallel to the line y equal minus 4? Or x equal minus 4? They're parallel, aren't they? Both are vertical. Their slopes are both undefined. Undefined slopes are vertical lines. So they're parallel. All right, so that's it.